me start my video and all this fun and exciting stuff.
All right, so welcome. This is our virtual meeting of the East Tennessee ISC Squared chapter at 6:30 p.m. on April 28th. And we are welcoming, we are welcoming Wesley Kirkland, who has self-professed himself to be the master of disaster, currently serving as senior systems engineer at Ministry Brands. He's going to talk to us about DNS. Take it away.
Let me get the slide deck rolling first because it's just all kind of upset. Cool, here we go. That should be working. I'm Wesley Kirkland on this. This is now my second ever virtual presentation. So on the, well, we've got a very limited crowd tonight, so it might turn a little bit more into one-on-one discussions, but hopefully there's some really good content that comes out of this. Just a little bit about me on it. Currently, as John said, my name is Wesley Kirkland, Senior System Engineer at a local Knoxville company called Ministry Brands. This is just a list of some of my more varied, prouder accomplishments. There's an echo there for some reason. But yeah, I've been doing DNS and domains for what, the past year and a half, 2 years at this point, and gotten very, very into everything that we're utilizing there. In correction, the title is Meme Master. So since we're at it, dating in your 30s is a lot like registering a domain name. The good ones are always taken, but you can always get one from an exotic country. I always have to put some kind of humor in it. So to focus on this, there's a couple core aspects that we need to actually understand about domain names. The first one is going to be a TLD. You generally hear that term a lot, but what it actually is in reference to is the top-level domain. Whenever you look at a URL and, for example, if you string split on a dots splitting path and query parameters, it's going to be the rightmost, like your comms, net, orgs, info, biz, LAN, works, so on and so forth. The next one is what's going to be a registry versus a registrar. So a registrar is typically what you might know as Namecheap, Name.com, GoDaddy, more enterprising ones such as MarkMonitor, CSC. You'll hear MarkMonitor throughout this talk quite often. And they are who is actually reselling you the domain and who you interact with on a daily basis for buying, managing your domain, so on and so forth. While a registry is going to be the company that actually owns that domain or owns the TLD. For example, VeriSign owns .com, Phyllis owns info and .biz, I believe. The next term is going to be a registrant. So a registrant is the legal person that actually owns a domain, whether or not your company is acting as a legal person. In the case of like Cisco and Amazon, so on and so forth, or if I, Wesley, am acting as that legal person, especially for a personal domain name, as I'm not going to register it to a LLC because I just don't have one. The next term is going to be your next term is going to be GTLDs versus CCTLDs. GTLD is going to be what's called a generic top-level domain. It's going to be your ComNet, org, biz, works, LAN, so on and so forth. And those have two subcategorizations: legacy GTLDs, which is going to be your ComNet, org, biz, info, what we all knew kind of growing up in the internet space. And then your other one is going to be a new GTLD, which is going to be the land in the works and gosh, there's so many, .fun, .space, .site, .website, .email, so on and so forth. And there's those two distinct categorizations, as some laws and various processes and procedures kind of vary between the two. And then the next major one is going to be CCTLD. The CCTLD stands for Country Code TLD. These are actually designated from the ISO 3166-1 standard, and the UN is the legal entity / authority that actually updates that. So it's always going to be the two-letter country code, except when it's not, because we work in IT, unfortunately. And the except when it's not comment kind of refers to the Great Britain, or the UK is one of them. They have .UK when their actual country code is GBR, and so they kind of have a two-letter designation, as they have many names. unfortunately. So one thing to note on this, GTLDs are all managed and accredited by the legal body of ICANN, while CCTLDs actually aren't. They're managed by their country that actually owns the two-letter country code designated from the ISO standard. There is some interesting things on there. So like ICANN can mandate and say, you must do this, while if it's a country like .io, for example, they can say, we can do whatever we want, because we don't have to listen to you. There are 50 plus different variations of agreements between various CCTLD operators, also known as countries in this, that have agreements with ICANN. So ICANN kind of has some overarching authority to a degree within these. Next one is going to be our TLD registration models. Here on the left is what you're probably most familiar with. It's a GTLD model. So ICANN is overarching authority, registry, for example, VeriSign, or registrar, GoDaddy. Registrar is also acting as your reseller in most cases, and then the legal person is the registrant. And a couple other models is you have a registry/registrar model with CCTLDs. It's the exact same thing as a GTLD model. There's just no overarching ICANN. The next one is going to be our CCTLD model of registry/registrant. It's a little bit harder to see on this, but the registry is selling directly to the registrant. There's no registrar and there's no reseller in there. Then you also have a mixed model. The mixed model, for example, like .uk has that model, I believe, and then there's a couple other ones. DO maybe for the Dominican Republic. But you can either go through the traditional model or you can go direct to the registry. Direct to registry is really great if you have like one off domain, but it's also really nice if you go through a mixed model if you're buying your domains through a GoDaddy or a Markmont or a CSC. So within GTLDs, there's an actual lifecycle process that most people aren't familiar with. The first one is going to be your registered term. Note it can only go up to 10. Some registrars out there, GoDaddy has done it before, but they'll sell you like a 20-year domain term. So you can pay for 20 years up front, but they can only register it for 10 years. So as soon as that term goes down to 9 years, they're going to add another year on top, and they're just going to keep doing that and to fulfill your 10-year term. You also have a 5-day grace period for, it's called an add period. So within 5 days, if you bought a domain name and it's GTLD, you can get your money back. If you say, oh crap, we're not going to launch this product anymore. Hopefully, if you have those issues, you probably should research marketing departments at that point. But after a domain is registered, you're done with it. Assuming you expire it out, it goes to expired. Then it goes into an auto-renew grace period, 0 to 45 days. The note on it of the domain may exist in the zone file. It varies by the registrar, but like GoDaddy, for example, they'll actually hold the domain for you, I believe, and so it will still operate for say up to 45 days, and they'll sit there and say, hey, are you sure you don't want it? Are you sure you don't want to pay us money? We'll give you great discounts. But after that, that's when the domain no longer functions and it goes into a redemption period, and basically you still have 30 days to buy the domain in case you just forgot to pay it. You'll kind of see there's a lot of grace periods with GTLDs. Note, does not apply to CCTLDs. After the redemption grace period, it goes into delete, and then it's releasing. The whole process starts right over again. So within this, you have first, second, and third level domains. We, as regular people and legal people, cannot buy first level domains, except when we can, which we'll get into later. But so what it actually is, .com, .org, so on and so forth, that's going to be your first level. Google, Amazon, Facebook, .com, that's all going to be your second level. While there are countries, the UK is for one, you might have seen a lot of company.co.uk, and so on and so forth, or parliament.gov.uk, so on and so forth, and they'll always register on the third level while they use the second level for legal designations on how to do specific things. There's also Brazil and France, they like to use a third level designation a lot of times to help say, well, like law firms could buy .law or financial firms could buy like .fin, and that'd be like my company.law.br is Brazil, I believe, and .financial or mycompany.fin.fr. Note this probably aren't the true designations, but the point still stands for it. A kind of interesting note on this is back in 2011, UK actually went into a period called land rush, which is, as the name kind of implies, people coming in to buy their domain names. So if they had valid trademarks through the TMCH, they were allowed to go in and actually buy the .uk iteration of their domain instead of just keeping on the co.uk. So that way they actually can operate down as the second level instead of a third level. The next status is going to be, these are EPP status codes. They stand for Extensible Provisioning Protocol. So I want to point this out because they're actually incredibly useful for helping to diagnose issues with domains. For example, at my work, we host a lot of customer websites. So a lot of times customers will call and say, I can't load my website. Well, they're the only customer on that web server that's having that issue. People say, okay, well, maybe it's this. Let's go bounce IIS or reboot Apache. Still doesn't come up. And if they actually would have taken the time to look at the EPP status codes from a simple whois or RDAP query, they could say, oh, well, this domain is suspended due to X reasons. And the codes can kind of help explain what's going on. Talked about add period earlier. Auto renew period is pretty self-explanatory. Okay, the domain's just okay. Note, I'll get into it in a minute, but you generally don't want to see okay. You want to see some kind of prohibited code. Pending create, you'll almost never see it unless there's just a lot of delays in the provisioning process. You might see it for like 1 to 5 seconds when you buy a domain, but that's about it. It just means it's still being provisioned on the back end. Redemption period, we covered earlier. Renew period, it's pretty much the same thing as add period, but you can get a refund if your domain accidentally auto-renewed and you don't want to pay for it. Note, a lot of this is kind of subject to registrar interpretation. ICANN enforcement is kind of difficult to do, as I've learned with many complaint tickets. Then there's a couple client codes, or one thing to note too, this is not a complete list, but a lot of the client codes are kind of important. So client delete prohibited, if there's a legal battle going on with your domain, whether you're aware of it as a legal person or not. You might be prohibited from deleting your domain name. You might be prohibited from renewing it, transferring it, updating it. But generally seeing like a client transfer prohibited is a good thing. It allows you to say, well, it allows you to reject any kind of transfers. So that's where you want to see that instead of no K code, along with a couple of others. And then you can kind of see them once you start probing online. But that, if you've ever been in like Network Solutions or GoDaddy, there's a domain lock or transfer lock. Having that on will give a client transfer prohibited on there. So on this, I was talking about some prohibited, so there's also server prohibited codes. Hey, we got another pending. So there's a couple other codes that you can use. On the left, I'm using my employer's website and Cisco.com. So what there actually is, when you see all these codes, there's a couple different variations called locks. There's a premium locking, and then there's a registry lock. Those are specific to Mark Monitor terms. They may apply across to other registrars, but I would assume that they would. So what they actually are, if you have a premium lock, for example, it's just going to have your domain locked within the actual portal of there. So if you're in a Mark Monitor or GoDaddy or a CSC of the world or Namecheap, whatever, you actually would go in there and you wouldn't be allowed to make any kind of updates to the domain name, whether or not you want to update contact information, transfer it out, add a note, so on and so forth. They would ban you from doing it until going through your process. And that's specifically going to be on your client codes as we, the client. The server codes are where it gets really interesting, and that comes down to what's called a registry lock. So it's the same thing as the it's the same thing as premium lock, but there's an extra step where it actually is locked at the registry. So VeriSign or Phyllis or whatever is your registry, and they offer that locking. Note, not everyone offers it. Donuts operates a lot of new GTLDs, and they don't offer it for any of them. But what they do is it's locked inside of your actual registrar portal, and then it's also locked within the registry. So to unlock it, you'd have to go through your process that you have designated with your registrar. For example, ours is a very custom process with a bunch of miscellaneous phrases. And then once they do that, then Mark Monitor has to go in and they have to unlock it on their side. And then from there, they actually have to call up VeriSign while they're in business, multi-factor with them, authorize it, and then the domain's only unlocked for a 15-minute period. So you only have a 15-minute period where a domain can actually be hijacked. So that was kind of an interesting story on that. Cisco.com used to be with CSC Domains, and I was talking to them earlier or late last year. And what they did is they had to transfer from CSC to Mark Monitor. So they actually had to go through that entire process as they were registry locked already. So they had to go through the process to be able to switch domains. And on the right, I wanted to illustrate. So I just picked two domains, camel, 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 and my personal domain. The status code on camel, 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 it's where I was talking earlier, where you don't necessarily want to see an OK code. You want to see something of transfer prohibited, preferably client transfer prohibited at a minimum. And that will actually help make sure your domain doesn't actually get hijacked. Now on the bottom is mine. It's the same status. It just happened to be in a renew period, which means if I accidentally renewed that domain, then I can get my money back within X time. So one interesting note I wanted to point out is on the actual right-hand side, even though this is Amazon Registrar and Gandy, they're actually both operated by Gandy. Amazon's just a massive reseller for Gandy. So .brand, you can actually own a TLD. Couple of popular examples of it are .newstar, Fox, KPMG, AWS, Toyota, Google, so on and so forth. There's a really great example with KPMG where they really embrace it. So if you actually go back to, oh, my computer's off right now. KPMG.com, what will actually happen is they'll redirect me to home.kpmg. They've really taken that .brand presence and tried to really put everything that they have on it. To get this, you have to be registered through what's called the TMCH or Trademark Clearinghouse to get that. Then there's tons of fees. You actually can't get them anymore until ICANN does another phase or does another sunrise period for them. But all these came into effect in 2013. The application fee alone was $185,000 per .brand. Note Amazon and Google own several of them. That fee did not include your in-house legal fees or any other miscellaneous paperwork fees. And if your application was approved, you had to pay $25,000 a year on top of it just to continue operating your .brand, as well as a per domain fee. You get 10 domains for free, and after that, you either have to buy direct from the registry or go through your reseller there. So this is where it gets a little bit interactive. Hopefully this works on this call. But name that TLD. Does anyone know who .io belongs to? Kevin, Jared?
I am not sure.
See, in the first call, I was going to say IEEE. You know, IO, nah.
No. So this kind of gets into IT likes to register a lot of funky domains because they fit IT initialisms or acronyms, and it gets really fun. So IO is actually for the British Indian Ocean Territory. What about
Interesting. Oh, Transylvania. I have no idea.
That's the answer everyone gives, and it's always wrong. It's actually for Tuvalu.
Okay,
Oh, wow.
Well, yeah, there you go.
What about
Didn't know
.me? Yeah, I know. What about .me? No guesses?
Macedonia.
No,
Mexico.
close try. It's Montenegro.
Oh, yeah, that's pretty close. They're close
Yeah.
together.
Yeah, maybe on a world map, I'd have to look. One thing to note is I have GCC TLDs here, and that's a specific SEO classification. They will find CCTLDs and they'll say, okay, well, we realize that these actually have a lot greater uses, especially within IT, like Plex.tv, for example, or Chef.io. So they treat them as GTLDs from an SEO ranking instead of saying, well, this is in that country's specific language by default. What about .ai? It's going to be Angola.
Angola. Okay.
Now, what about .app?
Appalachia.
So I'll tell you that's wrong. And if you think back to like slide number 2, the answer was there.
Okay.
Any ideas, Kevin? Jared?
Yeah, I don't know, man. Not
So,
sure.
It's actually not a CCTLD, it's a GTLD. CCTLDs are always 2 letters. So
That's right. Okay, trick question.
Exactly, that's the point. So a little kind of fun thing is the Charleston Road Registry, it's actually Google. And if you've ever, most people don't know it, but Googleplex is facing one road, and but the road directly behind the Googleplex is Charleston Road. So that's where they get that term from. What about .hr?
Honduras. I don't know.
No, but close. That would be like HO or HU probably. It's actually Croatia. In the Croatian language, their alphabet's entirely different, so they get .hr. .fm.
French Martinique, I don't know.
That is a really good guess. It's the Federated States of Micronesia.
Oh, there you go. Okay.
So random.
Yeah, well, like last.fm. That's where I got it from. We only got 2 more. .mc, and no, MC Hammer does not have it.
Dang it. That was
I'm going
gonna
with
be hard.
Macedonia. I'm going with Macedonia again.
No, it's Monaco.
What?
Get familiar with ISO 3166, specifically revision 1. Woohoo!
Yes, sir.
If you follow me on Twitter, you already know the answer to this one. It's actually for Armenia, and they are absolutely awful to deal with. I hate the Armenian ISC society. Not this ISC, completely different ISC. Where I was talking about earlier, CC-TLDs don't have any or have to abide by ICANN authority. They also don't have to abide by American law, which is a real annoying thing sometimes. And I've been battling with Armenia for a freaking year over a domain. I also had to battle with the Dominican Republic. I found the one lady on the entire island that can speak English and solve my problem. And it only took me like 3 months to find her. Because we were having, they kept saying the contact or the contact ID was wrong. And we're like, well, tell us what it is. We don't know what it is. We just know it's wrong. Well, that's insanely not useful. Ugh. So on next one is CC-TLD issues. So this is kind of geared towards, if you're going to use a CC-TLD, make sure you investigate what's going on. .io, one guy accidentally took control over the entire IO namespace by registering a domain. He was using a DNS visualization tool that we'll use later today, or later in this talk. And in there, he found a couple domains that were listed in the root, but they weren't actually being used. So it's like, okay, well, sometimes this happens, and they'll block them from registration. That's perfectly normal. It just spells out. It's how DNS is designed to work, except when it's not. So he registered the domain. 5 minutes later, and like $60, he had it in his name server. Okay, let's go set up a bind server. Set that up, instantly start looking at logs, and congrats, he's now one of the 4 name servers for the IO namespace, and accidentally took control. That security researcher didn't actually do the right thing, went ahead and bought the other ones, emailed them within 24, 48 hours, had his full payment refunded, and then they had registered those domains and put them into action or blocked them. So they did, British Indian Oceans did their job there. Another one is .ly. Note this one did not affect Bitly. It affected Literally, was the main one in the news. But CC-TLDs, since they don't have to operate by ICANN, they also don't have a lot of automation sometimes. And sometimes it's like 2 or 3, maybe 10 people sitting in an office manually doing paperwork. Libya had a civil war going on, and there was no one in the office to process renewals. So Literally couldn't renew their domain name. .inq is already in there, but Algeria and Iraq, they shut down the internet so their students couldn't cheat. Well, the root name servers happen to be hosted in the country, and whoops, no one could resolve a .iq one. And .eu is really interesting. So everyone's familiar with Brexit, I hope, by this point, for better or for worse. But to have a .eu domain, you must live in the European Union. congrats, if you're a legal person, company or person in Britain, and you didn't update your info, your domain got suspended. And they've already started, this suspension period's been running for quite a while. And they'll actually start finally revoking all the domains later this year. So you had an option to go ahead and update your contact information beforehand to somewhere in the EU that's not the UK, Northern Ireland, or Gibraltar, as those were UK properties at that point, or that qualified for the EU. So you had to update your contact information. And if you didn't, or use a local presence option offered for various companies, Mark Monitor, CSC, GoDaddy might even offer one, I have no idea, then you lost your domain. We've actually got a few of these at my company that I need to go through and resolve once I get a handle on them. Oh, one thing to note too, if you are going to buy a ccTLD, if you ask if they have a registry lock and they say yes, it's pretty much a safe gamble that they're going to operate as a real reputable TLD operator, and you're not going to get your domain stolen or taken away or have international law conflicts, so on and so forth. So the next one is going to be IDNs, or also known as internationalized domain names. So the first one is it's actually a Reddit post that you can see once we have the slide deck published. But they bought an IDN of Google.com. Specifically, their G's were slightly different, but you'll notice how text renders in this that it looks exactly the same. So if you're going to go sit there and fish, you could even do DeMarc on it and act as your own Google.com. Note, if you send it to Gmail, they're probably going to block it. But depending on who you're sending it to, they may not. Mimecast may not even. I have no idea. But so they bought it, and now they just have it redirecting to a help desk button site. So you can go click a button, and it opens up your help desk and logs stuff. It's kind of cool. But so what I actually did is I went out and registered PayPal.com. So I'll go ahead and open it up here from the speaker notes, and then we'll go ahead and view the redirect path. Please do note, I know it says bit.ly, but I only had to use bit.ly because Google Slides doesn't recognize IDNs as being valid domain names for security reasons. So on and so forth there. But I personally own PayPal.com for $7 a year right now, their name, and it redirects to my website. You will see in here though, they're actually using, or XN-- is the prefix for IDNs in all major browsers. If you actually go and view it, if I wasn't doing a 300 series redirect, it would actually, most browsers show the XN- to kind of give the user saying, hey, you're on an IDN website, instead of accidentally trying to fool them, because then we can run like, I think the man-in-the-middle proxy is Medushkin or something. And I saw a company do, SegaSec, they bought their own IDN of PayPal, ran it through that proxy, sat there, sniffed the tokens, and then ended up doing a DOM object injection. And it's like, congrats, you have $5 billion in your bank account. Well, that's clearly not right. So you can do a lot of tricks with IDNs, and they're a really cool company. You should check them out for what they do. But there's a couple of legalities here. I had to sit there and explain first to Namecheap until I realized Namecheap wasn't going to get me anywhere. But I had to sit there and explain to Namecheap and Name.com that I am a legal person. I'm not a spammer. I'm doing this for a legitimate purpose, and I'm not going to violate their trademark. So while PayPal does actually have a domain block, at least to my knowledge they do, same thing with Google. We'll get into those here in a minute. But these, it depends on the character set and so on and so forth, if that homograph is going to be covered within the domain block. So like Namecheap, they initially tried to deny me from buying my own iteration of PayPal.com because PayPal is a well-known brand. And I sit there and explain to them, here's the legal law that says why I can buy this, and that I'm not going to violate it. And if I do, I understand I will not get my refund as I committed some break of a law or whatever. And they could go through and do a URS or a UDRP request against me. But so there's fun things that you can do there. And the way I actually did this one is it's just sitting there and either copy and pasting characters from Wikipedia or using the Windows character map to go in and build up your own domain names. There is a variation of PayPal that I should have done, but I thought about it later, is it was replacing the A's with non-Latin characters and leaving the P and the Y alone, or the P's and the Y and the L alone. But that way I could kind of get it to where it looks more like the Google.com. So there's lots of different ways that you can do this. Granted, you can't ever tell someone the URL, but most scammers and everyone, they're not going to say, please go to google.com. They're going to say, let me send you a link, and you can click it from there. And on the domain blocks that I was referring to, if you have your trademark registered through the TMCH, Trademark Clearinghouse, if I specified earlier, you can buy what's called a domain block. And there's a couple different iterations, and Donuts has a really funny name, one called T-Rex, which I think is just great. But or what you do from there is, assuming you have your trademark through the TMCH, you can say, well, I want to, there's two different options. The first one is, please notify me if someone buys that domain name, or the second option of, please notify me I want to be in the sunrise periods or the early landslide. What is it? Early something period to buy a domain name at a highly inflated price. But some companies like Google and Facebook and Amazon care about that kind of stuff. New utility comes out, Amazon, Google, Facebook, Microsoft, they probably want that domain name at any cost. So what they do is when you buy these domain blocks, they'll generally give you a couple different misspellings, variations, sometimes some homographs, depending on the block package. And you can either buy the domain block and it either prevents people from registering it, and that's great from a webmaster perspective. But if you're focused on email security, spoofing, and impersonation, a lot of blocks will let you do, I forget the exact terminology for it, but it's kind of like a silent claim. So you can say, well, if my domain block covers 500 domain names, let me buy all 500 domain names. I'll put them in DNS. I'll put a demarc policy and an SPF hard fail on them and the demarc for reject. And we'll just block them, make sure no one can use us to phish us internally or phish our external customers utilizing IDNs, so on and so forth. So you can do a lot of powerful stuff. Now on those domain blocks, if you know that's the route you want to take, especially with like top one or top tier one brands, you can generally get those down instead of paying like $10, $20 a year per domain to like $2 or $3 a year per domain, just due to your buying in that massive bulk of a block. Also, too, when you're buying an IDN, you can't mix and match character sets. I originally tried to use a Cyrillic Y, and turns out that's not supported because I was using a different character set. So you can mix and match Latin versus non-Latin characters, but you can't go mix and match other alphabets like Cyrillic. So kind of an extension on this, the top right, my same domain name, I sent it to a friend. His iPhone didn't auto-unfurl the link, so if he clicked on it, it looks just like PayPal.com. There's very little signs to give it away, and then I could easily start stealing information there. On the bottom right was my Android phone. It automatically unfurled it, and the Y is a lot more pronounced. So again, it kind of goes with the character set of what you're utilizing. So time for DNS. Some might say the first part was more boring. Some might say this part's more boring. Who knows? So a little joke and something I actually used to have hanging in my cube at a previous job. It's not DNS. There's no way it's DNS. It was DNS. It's from Reddit, and it's still true to this day. Even when you think an issue can't be DNS, it can be. I ran into a proxy issue one time. Turns out I didn't have a reverse DNS entry. Whoops. So to actually get really deep in the DNS, you can go all the way down. It's kind of a deep slide to start on, but name server architecture. For the purpose of this talk, we'll actually look at 10-sec.org, which is where our ISC2 chapter is hosting from. So we can go in and start to view the DNS visualization for how this is all laid out. Whoops. So we can say, okay, 10-sec.org relies upon Azure DNS. That's great. So we see each one of these. We have our TLDs, com, net, info, org. Okay, well, each one of these is going to go back down to their respective zone. All of them are going to Azure DNS, com, net, info, org, so on and so forth. It's kind of a one-to-one mapping. And then all those are going to go down to Microsoft's name servers. So we can already start to see, okay, that's where a single point of issue is almost. And you can make this as broad or as narrow as you want. Both have their own pros and cons for doing it. So we can go in and actually say, okay, well, let's go find the actual .com one. So .com is dependent upon the .net namespace. And if you go back down and deep into internet history, .com was meant for commercial enterprises and companies, while .net was meant for anything network related. So that's where that kind of comes from. So .net is relying upon itself as indicated by the dot for the root zone there. And of course, net, com, everything's delegated out from the root. But we can go back up here and look and say, okay, well, net. It's going to trace right back down to the same thing. Virtually, it's just one less layer of abstraction. Okay, well, we can go look at org now, for example. Org, turns out, Phyllis is the registry for them. So they're operating it. So we can kind of get a little bit more down in there. And it's like, okay, well, org is actually utilizing info there again. And we can just keep tracing it down, down, down until we get sick and tired of it. A really fun one, though, is actually if we look at PayPal.com, because one, their DNS architecture underneath the hood is insanely complex. It's not very complex, it's very large. And hopefully I can find it this go around. But what we can see is PayPal.com, what they're actually doing is they're running on two different name server providers, DNS, I forget who that is, and Ultra DNS. So the Dyn one, okay, well, it looks pretty all right. That's kind of cool. Oh my gosh, that extends really freaking far. But what we can start looking at is, okay, well, they're utilizing Ultra DNS as their secondary set. Well, that's fun. Let's go see what we can find there. Okay, so Ultra DNS, eventually they're going to rely upon ultradns.co.uk. So if you remember from earlier, ccTLD issues. Thankfully, Britain seems to be very politically stable at this point. Maybe they have some other ones. So we can go ahead and trace this down to just ultradns.net, which of course is what they're hosting their name servers off of. Hey, look at that. Ultradns.net is actually hosting one of their name servers from .net.au. Thankfully, Australia is very geopolitically stable as well, but you can kind of start to see, okay, to get widespread DNS architecture, you can either rely upon ICANN accredited stuff or you can rely upon other countries, so on and so forth. It's depending on who's controlling it. Some might also see this as an additional redundancy layer. Many different ways to see it, and if you have ITAR compliance, you can't use Ultra DNS. It's physically against the law for you to. You would have to host everything within the US, preferably on your own name servers, so on and so forth from there. But, or as I was showing, you can get really deep into the DNS architecture. So on our next slide, it's just kind of a reminder of DNS queries. Your client's always going to go to the DNS server/forwarder. We're just going to assume that there's no forwarder for this. So the DNS server is going to go directly to root. The root's going to send to the TLD namespace, most likely .com, and then that TLD namespace is going to send this down to the authoritative name servers. Now what's really interesting on this one is if the root DNS servers have the glue records, which they almost always should, you can actually avoid going directly to the TLD namespace because they'll send us those glue records and they become shortcuts for there. And we can also see this by utilizing dig. Well, not the glue records per se, they're hard to visualize, but we can see, okay, we go to root, then down to the nic.me name servers, and then nic.me sending to Cloudflare for my personal domain for there. So, and we have that, and just a note too, root DNS servers are always anycast via BGP, so they're operating across the entire world. Of course, those are managed by ICANN. ICANN manages them. So that way there is lots of network level redundancy from there. So a fun thing that we can actually do, and this is what I really like, DNS text records specifically, you can really exploit. And to start on this, if DNS records by default, they actually utilize UDP for their transmission protocol on Ethernet. So of course UDP, there's no redundancies. Do you get a packet? I have no idea. I'll tell you a joke, but I didn't get it. So once they go over 512 bytes, which is going to be 2 DNS text records maxed out, they'll actually fail over to TCP. Granted, if you have 2 records, it will come back generally as 2 UDP packets. But with the text record, you can get up to 254 bytes, each byte representing a single character in this case. So you can do string concatenation, and you can do this with SPF records a lot of times. You also have SPF include services like Agari. Then there's a couple other smaller ones. DeMarchi, I think, is making one. But so you can go in and concatenate your text records, whether or not you have a very long DKIM string. 2048-bit always requires some string concatenation, while 1024-bit doesn't. Or you can just sit here and screw with them, and you can insert the first 400 lines of the Shrek script into a text record for your enjoyment. Unfortunately, when I was doing this, I learned Route 53 has more limits than I thought they did, aka 400 lines per resource record set, which kind of screwed me a little bit there. But and then since I don't really do any concatenation, as I couldn't get it to fully take it on when I was setting this up, they do come out of order, but you can generally put in whatever the heck you want for this. And I've done a couple concatenations, like 2 4 long, or 2 or 4 generally individual text records to come through in a single one. But you can also see that our initial response was truncated, so it's going to read, and I did not mean to click that. It was truncated, so it's going to go ahead and retry in TCP mode. So just to show the truncation there, some wire or screenshots and gifs of Wireshark. But normal DNS text record response, this is going to come through as protocol DNS, comes over UDP, so on, and you're done. But the actual one that I showed you of LOPS, that's not how that dot works. It's actually going to come through initially as UDP. It's going to be truncated, then it has to fail over to TCP. Specifically, we got 12 segments, 14 packets total. So that way we could actually get the full text record. So we can build our response for our client. Of course, that takes a little bit longer to do, but works much better and it's more efficient. Though, one thing to note, in DNS Flag Day 2019 helped this, I believe. They did eDNS version 1, but there's other things of where a lot of people had heavily misconfigured firewalls. Old Cisco ASAs did this a lot, but they would sit there and manipulate your packets and screw with eDNS. But they would also have it so DNS over TCP was blocked, because a lot of older school network guys, or network people or security people, they'll block TCP for DNS because TCP is traditionally used for zone transfers, and open zone transfers across the internet are insecure. So instead of utilizing a master-slave setup or copying zone files, they would just straight up block it, or do IP ACL restrictions for TCP, which screws with a lot of that. So there's some DNS tips and tricks I want to highlight. All of these are primarily specific to Amazon's Route 53 service, as they are very RFC compliant on how they handle everything. So the first one is going to be overriding wildcards. So for example, if you had wildcard.example.com and it's just an A record to Quad 1, yay, Cloudflare. But then you want to say, well, I have test.example.com and I need to have a text record. Most people would assume, okay, I already have my wildcard record sitting here, and now it's going to return Quad 1s for if the type A is queried, or it's going to return hello world if I query record type of text. If your DNS server is actually following specifications, the wildcard will actually fail second, and the most explicit record will win, in this case, the text record. We learned this at my employer when we accidentally caused a minor outage from one thing, because this was some obscure DNS thing we just didn't know at the time. Researched and, hey, look, it's really a thing. The next one's going to be, assuming this loads, CNAME on Apex. Providers like DME, or also known as DNS Made Easy, DN Simple, Azure DNS, Amazon Route 53, Cloudflare, they'll offer alias records, or CNAME flattening, as Cloudflare likes to call it. And the tech specs behind why you can't normally put a CNAME on the apex of a record is because for a CNAME to exist, it can be the one and only record on that record set, whether or not that's on the apex or somewhere else. So on your apex of the zone, you always have an NS record and you always have an SOA record. So it can't be the one and only record on there. And that's why you can't have it. Most websites are also going to operate MX records, so on and so forth. So that's why you can't do it. But Cloudflare does CNAME flattening. So they query out the A or the Quad A records on the fly from there. And then Amazon's Route 53 does alias records internally to their services. Azure DNS does alias records to their services. DNS Made Easy and DN Simple, they take a more A-name record approach, which is still more experimental, but they basically still qualify it down for as CNAME flattening on the apex. You can also do this with like Power DNS and Lua coding, so on and so forth, to do whatever you want to and resolve on the fly. There is a couple standards in spec right now. Right here's one from ISC. And this is the ISC I was referring to earlier, the Internet Systems Consortium. But there's various different articles and discussions on how can they actually make a name record's a thing. An A name record would kind of be like an MX record, but for HTTP. This one is red. That's no bueno. Did they update it? Oh, no, it expired earlier this year. That's nice. Oh, well. But, cool, so must not have a new one out there. Sorry. But that way you can actually get an A name record, which would act more as if a browser or something is requesting your website, please do give it the C name. That way it loads. Of course, if and when that's ever approved, it's going to take a couple of years before everything in the world starts to see it out there. The next one's going to be differences in C names. So, as I said earlier, a C name is supposed to be the one and only record for that record set. So if you had support.example.com and it was a C name to zendesk.com, and someone said, hey, I need to add a DCV verification for an SSL cert, it's just a simple text record. Put it on support.example.com. Route 53 will say, screw you, no. Other providers might take it, and then they'll start overriding it and say, well, your C name no longer resolves. Only your text record does. And you kind of get like an overriding wildcard scenario. And from there, it really kind of depends. Proper DNS server implementations will do what I just said, but improper ones, or as they might say, features for theirs, they will say, okay, well, if you request a text record, we'll return your DNS verification record. Or if you request a record or a quad AMX or anything else, we'll return whatever goes to Zendesk, as that's what your C name is going to. So the next one is further exploration of DNS. We're not going to go here. I think it's a pretty funny video. This guy named Neil, he goes into like an 18-20 minute in-depth DNS explanation, and it's very good, very eccentric and very out there though. But he does a really good job of explaining it. The next one is going to be administration of DNS. And this is something I really never thought about until I put this talk together, even doing DNS in my day-to-day. But DNS requires expert administrators. If you don't have one, you need to hire one or learn how to be one, specifically with some test zones. As I told you, we've taken down a couple of things because we didn't fully understand DNS like we thought we did. And there were things there. But like at my employer, we migrated 1,300 plus corporate zones, and we've migrated thousands of other customer-related zones back and forth between systems. A lot of them were messed up and required a lot of fixing. Sometimes there's CNAME flattening, which is against DNS spec, but the provider let you do it at the time, so we can't migrate them, and you have to kind of leave them behind. And my personal stance is I don't really care what the provider fancy features are unless you know you're permanently going to be with them. But even then, permanence is only temporary, or being permanent is only temporary. Nothing is truly permanent in this world. And like if you were on Dyn, Oracle bought them, shut them down basically. That's not permanent now. You got to go find another provider. This is where you really need to become a DNS expert. And then the last one is going to be glue records. I referred to them on the DNS query side, but they're also known as shortcut records. But you need a glue record for like Google.com. Their name servers are ns134.google.com. Without a glue record, there would be a permanent loop, and it would never resolve for their. And oh, there's an extra space there. That's nice. Sorry, scroll. But you need the glue records as your shortcut records, and so that so the internet can figure out who you actually are. Because if you also think about it, there's a weird cyclic redundancy check there almost. And if your name servers go down, well, no one can ever answer for them. So you need those glue records, which are actually hosted at the registry, to say, this is where those name servers are. Please go there. I was working with a buddy last night, and off topic, I was going through his company's DNS. I was like, hey, you should really tell your company to fix their DNS because they only have glue records, and those glue records, when you resolve them directly, they don't actually respond to any values. That's an improper setup, and it's kind of a miracle your website and anything's loading. Is just getting really, really lucky that everything is really up to date. But if you get an out-of-date client, they're not going to load, and that's a problem for if you want business. And they were a tech company too. I know when I do vendor searches, if I can go probe it, and if I'm not happy with their tech stack, it might influence my decision because I can see how their tech stack's operating. Therefore, I might get a picture of how they operate from there. But so yeah, like I said, there's a lot of interesting things there. And then when I keep referring to the shortcuts, once they're cached, you don't have to go to the root and then the TLD servers. You just go directly to them for the length of the TTL that was returned when you actually query that A or the quad A record for it. The next one's going to be identity. I have a little bit of history in IAM as well, as some people can attest to. But DNS and domains are also the crucial component of identity. There's been so many different hijacking attempts out there. Someone took control of the domain or someone took control of the DNS zone. Well, once you take control of that, you're owned. It's like having physical access. You can change your email, then you can do an OTP code redirection. Maybe if you got smart about it, you might go in and set up your own thing, intercept it, and then just forward it back down along the chain. That way, hopefully you're never noticing until maybe the original actor finds that you were manipulating their data. Props to you if you can keep it in the same IP sending system. That'd be really cool to do from there. But so yeah, you can totally do that. Down at the bottom, the article from Cloudflare, it's really interesting. It's not entirely DNS related, but it shows how their CEO was compromised, but not by his acting, but strictly by social engineering through AT&T. That still went down and used identity portions outside of Matthew's Prince's control. Same concept applies towards DNS as a whole. Next one's going to be on DNSSEC. This is the part that I'm not very, I know enough about it, to say the least. But so you have 5 different record types for DNSSEC. Our first one's going to be the RSIG, or Resource Record Set Signature. It's just going to contain our digital signature of the resource record set. And I guess before I start on that, I should probably show what DNSSEC actually requires. So if you have example.com returns 3 A records. That's great. In bind, those are going to be 3 separate records as a whole. But, and say Route 53, Route 53 is a really bad example for this for other reasons. But they treat those as 3 individualized, or sorry, not as 3 individualized records, but as 1 resource record set, which seems great on paper for this, because to do this, you have to sign all of those resource records, and you have to group all 3 of them into a resource record set, and then sign that resource record set. And then, same thing, like if you had your MX records, everyone should always have more than 1 MX record. But so you need to have all those groups so you can actually sign them. But then you're going to have your DNS key that contains your KSK and your ZSK, which we'll get to here in a minute. Your DS record type is going to contain a hash of the DNS key record. Then INSEC and INSEC3. INSEC3 is it's a greater variation of INSEC because INSEC had some security vulnerabilities. The primary one being zone walking, which I'll see if I can pull up real quick. I did in demo earlier. But so if we go in and query out right here, we'll just take right, and then we'll say, well, give me your INSEC record type. There's an attribute of next domain name. So you can actually take this and you can walk the zone. It's like doing an open zone transfer, which is horribly insecure. DNS is, or one thing in security-wise, you should always consider DNS public record, even though it's not entirely public record. But if someone knows what they're looking for, it is public record. And this next domain name attribute was how DNSSEC explicitly said, hey, please quit querying me. There is nothing here, and I can prove to you that there's nothing here. But I built just a quick zone walk earlier. Still needs plenty of additions. But we can go through here. There's the entire DNS zone for RAP.net. They have a lot of service records that I couldn't get through in query in time, but you can kind of see what's going on there. And then my text records need some adjusting, but you kind of get the generalized idea there that we can go through and figure that out. Like stats.academy.rap.net goes to Stingray, which is a really interesting thing that you can sit there and do. But then you also have your CDNS key and your CDS. That's to do DNSSEC on child zones. So like If you had example.com and you also have prod.example.com and dev.example.com, prod.example.com might go to AWS account or Azure Sub 1, Dev, AWS Dev or Azure Dev accounts. So that way people can kind of control what DNS zones are actually hosting, and you can do some IAM programmatic updates from machines upon auto redeploy, so on and so forth. So there are needs for having child DNS zones. And on the DNSSEC record type, you actually have your ZSK and your KSK. The ZSK is going to be your zone signing key, while the KSK is going to be our key signing key. Zone signing key is what's going to sign individualized resource record sets, and the key signing key is what signs our ZSK right now. You can kind of see it here, and they've got the two different flags, 2 to the 8 or 2 to the 0 is a weird thing, and that's how Cloudflare's documentation has it written down. It's very strange. But you can kind of see what's there and how we actually get those keys. And then to actually verify our resource record set, what our resolver is going to do is going to query the resource record set. It's going to query our resource record signature. It's going to query our DNS key. So I'm not actually going to do a compare on the fly right now, but we can kind of see right now that hopefully this is still screen sharing. So we can take rack.net, and then we can also take our resource record signature. There's our signature for that entire resource record set, and then we can also take our DNS key. And those are the 3 elements that we actually need to go ahead and verify that out. So we'll take that, do all the computes, or do all the computing for us, and then send it to the resolver and basically say, A to go, or no, this isn't good. The problem is DNSSEC relies heavily upon the client to validate that it is an effective signature. And if you're going to go out and do attacks and so on and so forth, you might run a proxy or your own DNS server on the system, and you can easily manipulate that. Kind of an interesting thing, I think it was, 1996 is when they realized, hey, DNS isn't secure when you actually need to work on something. DNSSEC was actually a standard way back in the early 2010s. Then 2006, 2008, they just completely trashed what they had and did an entire new revision on it. So to actually verify out our ZSK for this, it's basically the same exact process as before, but we're going to take the public ZSK, which we can get from querying the DNSSEC record type. We'll also take our public KSK. Now this is where it's getting sketchy, that I don't remember. So we'll verify out the resource record signature of it against, I believe it's the DNSSEC resource record, and that's how we can verify that our ZSK is valid. And assuming that one's valid, you can still trace that up throughout the entire tree, all the way back up to the root servers on dot, because you're going to have your chain of trust as root, TLD, zone, and then our child zone. So I just wanted to illustrate out some useful tools that I used either during the making of this talk or that I use in my day-to-day life. MX Toolbox, if you're not familiar with it, you gotta be. It's a lifesaver. Even though you can do everything else in NS Lookup, Dig, or PowerShell, it's still way too useful, as they actually do a lot of syntax-based validation for you. Or say, well, like on DKIM keys, you can say you don't necessarily have to have B equals DKIM. You can get without it, and it's still technically valid, but syntactically inaccurate, or too many SPF lookups, so on and so forth. The view DNS info is really good. I had to use it a lot at work to help track down miscellaneous zones that I may or may not own or have control of, because what you can actually do is run like reverse whois lookups. It's a lot of aged data, but even having that aged data is very useful for helping find zone files. I say, well, I wonder if I actually own this zone. Like, these were a lot of zones that email address that my employer was used on, so on and so forth. And there's actually a couple there that I didn't realize that we owned that I might need to take a look at. But then there's also some reverse NS lookup. So if a company is running their own name servers, like we can run ns1.google.com through here, we can see, okay, well, here's a lot of zones that Google may or may not own. We can kind of see a lot of these they probably don't own, except for like those they definitely do, but I highly doubt they own those. But sometimes people randomly point their domain name to a miscellaneous name server just because they want to park it, so on and so forth. Various different ways of selling domains. The next one is DNS Viz. This is similar to what we utilized earlier, but instead it actually shows the DNS sec down the tree. So we can go down and query, say, my personal domain, and we can see how DNSSEC is propagating down the chain, starting at the root and then going to me, and then going to my actual domain name, along with the algorithm and the key links that were utilized during that. Next one is NTLD stats. It was actually down earlier today. Maybe it's up now. We'll see. Hey. So NTLD stats actually tracks new GTLDs or NGTLDs there. That's going to be like .land, .works, .fun, .website, so on and so forth, .email. And they track them, and they'll actually show the registrars that who has the most, how many deletions are scheduled in the next 30 days, how many domains were registered in the last 30 days, how many are parked, so on and so forth. You can get a lot of fun statistics from there just to figure out, like .icu here. .icu, .top, and .xyz are generally used as spam domains. Like you can buy a .top domain for $1 or $1.50 for the first year. So a lot of spammers like to do them. You can see upcoming deletes, 102,000, which is just insane right now. And how many domains there actually are of .icu and just their utilization over time. We can even expand this out and say, okay, well, that's when they started getting really popular, and now we can kind of see that they're falling back right now. A decentish amount, nothing to be too alarmed about, but as well as their NIC and their registry backend. Next one is ICANN Wiki. ICANN's data they're basically a public organization. I think they actually are. Everything's public record, so you can go there and get all their information. They have detailed statistics on basically everything, and if you want to go through and read their policies. Earlier in the talk I mentioned they had over 50+ registry agreements with CCTLDs. You can go read those. They're all public record, which is insanely useful to have. Come on, there we go. Next one's Dig Web Interface. I'm a Windows user, so I primarily utilize PowerShell or NSLookup, so I don't always have Dig available. Dig Web Interface is a fantastic web interface for me to go and actually get data that I need, because Dig does a lot of things that I can't do on my native Windows tooling. DNS Perf is basically it's the last real tool. It's really useful for if your company comes to you and says, hey, we actually need to evaluate DNS providers because we're having issues with our self-hosted. One, don't self-host. It's terrible. But we can see, okay, well, here's our authoritative DNS resolvers, and their statistics based upon miscellaneous probes all over the world, whether or not, and then we can also see, okay, is 8.8.8 and 8.4.4 having issues? They're serving getting all of that, like I said, from all over the world, and their query speeds, their uptime, everything. It's really great for seeing the world's DNS as a greater good, especially too if you say we are going to launch a European market and we're primarily American-based or South African-based or something. Let's make sure Europeans can access our records on our DNS zones and websites without incurring a bunch of latency. And the last one's going to be RFC 8499. It's just a gigantic RFC covering every in-depth DNS spec that you could ever ask for. It's really useful if you're on a website and they mention something you're not familiar with it and Google isn't immediately answering it. You go right to the RFC and then you can get through it. They've also got the current practices in here. It's just literally everything. And the last slide is my amazing contact information. Everyone in this recording actually personally knows me at this point. But for anyone watching the recording, this is how you can contact me if you're ever interested in learning more or seeing me just completely tell Rackspace they're wrong over Twitter. That one's really fun to do. But other than that, I don't have anything else. Any questions?
All right, so I've got a question for you. What are your thoughts on the corp.com domain and the recent debates about it?
Oh, that domain. Oh, crap. So Microsoft actually did offer that guy money. And
I think they finally bought it just last week. Oh, did they
finally?
I think so.
Oh, that's news to me then. For anyone not aware, corp.com is actually hard-coded into Windows in a lot of places. Brian Krebs reported on it back in February. I'm actually pulling this up now because I'm kind of curious. Did he buy it? I don't think they did. Let's see. Yeah, no, that guy still owns it. Microsoft didn't buy it.
Interesting. That was reported in several different.
Well, I mean, we can go look
interesting. Yeah.
Microsoft. They use Mark Monitor and cum laude domains sometimes. I'd have to find out more, but I mean, it's a private registration, and I know it's not just GDPR redacted through the Whois protocol due to how it's actually showing here. Fun fact, a lot of domains, even if like you go to whois.com and they're redacted, you can go to their actual registrar and you can use their Whois service and you'll get a lot of the information unless they really are redacted or using a privacy service or just GDPR. But corp.com, it is kind of dangerous as it's hard-coded into Windows in a lot of places. Microsoft did offer him $20K during this a couple of years ago, and he said, no, I'm not going to do that. Any other questions?
Krebs reported it on the 7th. That's interesting. I'll have to dig into that more.
Well, he should really update his previous article. It's also possible maybe Microsoft has a holding account.
They may have agreed to buy it, and they're just waiting to get all the money transfers. But so
yeah.
With that in place, obviously there's some interesting challenges there. If I have my company as Billy Bob's Widgets .corp, and it doesn't happen to resolve for anything, and then it backs down to says, well, let's try a .com. Obviously that can.
If you had a weird DNS suffix of .com, then yes. Otherwise, no.
Okay.
Like I know, a decade plus ago, I used to say, why wouldn't I add a DNS suffix of google.com? That seems like a great idea. Yeah, it turns out it wasn't.
Any other questions? This was an amazing presentation.
Yes, Wesley, it was very good. I've got a lot of food for thought, and it's something I didn't know a whole lot about, but there's definitely a lot to see here. I did have one question. You're using, I think, I'm trying to see the name of the website if I grabbed it here. You're doing some graphing from, I think, Transitive Trusts from VeriSign Labs earlier. Is that right?
Yeah.
Okay. I just wanted to verify that information. I wanted to go try that out. That looked like a lot of fun.
Yeah, there's that tool or a very similar tool is what the guy that Compromise.io used.
Okay. All right. That was very interesting. Just looking at all those trusts and processes and everything there. So definitely want to check that out.
Yeah. Or like I was saying earlier, you can either expand what you rely upon, or you can say, I just want to rely upon .net.
Okay.
And I've just dropped that link for the TransTrust of Verizon Labs in the chat.
All right. Thank you, John. I appreciate that.
Jared, welcome. You joined us a little bit late, so you missed my announcement earlier. If you currently hold an active ISC2 cert and you want to get CPEs for this, put your ISC2 number in the chat, and I'll make sure that those get recorded and automatically applied to you. If you want us to send you a certificate that says you've attended so you can get CPEs, drop me an email. Put your email